All right. Well, thank you all for joining today. I'm Alex Shore, the managing partner of GridVest. We are really excited to have an awesome panel, as you can see here today, to discuss how we simplify the deployment of behind-the-meter battery storage. In particular, we are thinking about everything from commercial and industrial on up, with a specialization or focus on behind-the-meter projects. That has been an area that has been the most challenging to figure out and has been one that we are trying to demystify today. So, with that, I'm going to just do a little housekeeping, and then we'll dive into the presentation. So, first of all, again, thank you for coming. So, as we move into 2025, battery energy storage is becoming more critical than ever for businesses, schools, and organizations looking to cut costs, enhance sustainability, and stay ahead of regulatory changes. Today, we brought together these three experts here on battery energy storage. Each of them will talk for 5 to 7 minutes on their area of expertise, and then we'll go straight into the panel discussion followed by a Q&A. So if you have any questions, feel free to ask it in the Q&A portion of the webinar, and we'll try to go through them as many as we can. And yeah, so with that, Andy, if you don't mind going to the next slide here, and kick off to the next one more ahead. And yeah, I wanted to start by just sharing, obviously, a lot of people in the industry have seen some big news in battery storage. And the one thing we're all trying to figure out is how do we navigate this new world of increasing power demand? With AI, obviously it was crypto, over the last 10 years, but really in the last 3 to 5, it's been AI driven in particular, but obviously electrification of buildings, EVs, and especially in terms of, ports and EV electric boats and all of the rest that's coming. Electrification is taking over, and we need power. There's no question about it. And most electrical grids, especially in the US, are not set up for increasing power demand. We've had decreasing power demand for many years, and now starting to have a radical increase again. And solutions are needed. So we can go to the next slide. We have also seen in particular California, where GridVest is based, and where I'm based as well at the moment, a huge amount of renewable energy, especially solar power, and a lot of that is getting curtailed and not utilized fully. So another need for battery storage, in particular behind the meter storage, and that is also basically what the new net energy metering tariffs have encouraged. It really is no longer economic to deploy rooftop solar beyond a certain size without battery storage. And at the same time, battery storage costs have dropped precipitously in the last year and a half or so. We've seen amazing decreases in battery storage costs, and it's driven huge demand, and it's made the economics of projects very attractive. You can go to the next slide. And battery storage has hit record in 2024. You can go to the next slide. And here are some of the data. This is, again, the whole market, not just behind the meter, but just to share, where we've come from. It's pretty unbelievable how far we've come in such a short period of time. This is very similar to what we saw in solar, as the cost of solar PV plummeted and the economics got more attractive, and the permitting processes got easier, and the just general acceptance became greater. And I think we're seeing the same curve starting to radically increase in battery storage. Next slide. And California and Texas are the two states that are still dominating this world. But other states are starting to catch up pretty aggressively. And especially in the East Coast, we're starting to see a lot of demand. And then obviously continuing in other the big markets. So we're excited to see where this goes. And just wanted to, before I move on to introducing the panelists, want to just give a little bit of background on GridVest. So you can go to the next slide. Basically, GridVest is here because we know about the challenges in battery storage deployment. There's battery storage equipment is really hard to vet. The quality can be hit or miss. The cost is quite high. There's unreliable suppliers out there. There's complex logistics getting equipment on the ground. it's expensive, which is again where we solve because we have our own flexible payment options. So we basically provide capital. We have our own capital and we provide flexible payment terms to any customer who is working with us. And on top of that, we help with integration, which we know is a tough part of battery storage. Right? You have a battery, you have an inverter, you have an energy management system. We help to bring the pieces together and pull in the experts who, again, some of which you have on the call today to help make these battery storage solutions possible. And um, the last part is really about turnkey logistics. So again, from what we offer is, as you can see on the screen, we have high-end products. So we source from tier one suppliers. We work with who I spent 9 years in China working with a lot of them. Luckily, I speak a little Chinese, so that helps too. And we have basically managed our logistics and supply chain very well. So we have turnkey logistics, and again, lastly, flexible financing. So that's GridVest. We'd love to talk to you. If you have any questions about battery storage, please reach out during, after, or the webinar. And but yeah, now let's go into a quick poll just to get a sense of who's on the call here. We're going to launch a short one here, which is about your role in the industry. And so if you don't mind just quickly filling out the poll here, it should pop up on your screen, and then we will share the results. I'll give it like 10 more seconds. We've got 35%, 50%. So this kind of just gives us a sense of who's on the call today and where we're at. So I'll give it another second here. And as you can see the results, so everyone should be able to see the results here. That is basically, we have a number of suppliers in the call. About 1/3 are developers, and then a large chunk are EPCs or installers. So we've a good turnout here today, and we have one more poll we'd like to do, and then we will move on to the intros. So one more real quick. And now we'd like to do biggest hurdles to battery storage. So if you don't mind filling out, we'd love to hear what are you seeing in the market? What's the hardest part for you in deploying battery storage, or what, and depend no matter what your role is. Is it financing and high upfront costs? Is it project economics and ROI, return on investment? Maybe permitting and policies? Um, how about availability of equipment, lead time of batteries, complexity of integration? Um, it's uh, it's quite it's quite a wide range of options here, but we'd love to hear from you. Give just a few more seconds here. Okay, right now financing and high upfront costs is in the lead. We have project economics. Let's see if it's all pretty close here. So any other votes would be very. All right. 3, 2, 1. Here we go. Ending the poll. Sharing results. So you can see there's a lot of issues basically. Financing and high upfront costs seem to be the biggest, and going down into complexity of integration being the lowest. But all of them are challenges, and again, this is just shows the world we're in. So hopefully, panelists, you've got your work cut out for you in terms of sharing more, answering some of these questions here. All right, great. Well, let's move on from the polls, and I think we can jump into the next slide here. I am, and here we go. First we have going to introduce the panelists. So we have three panelists here today. Again, thank you for joining us so much. The first panelist and our first speaker, Dan Martin, is the founder and CEO of AMP Solutions, which is a solar and energy solution provider specializing in behind-the-meter storage for commercial and industrial customers, and solar as well. Over the last 10 years, Dan has been bringing solar and microgrid projects to life from soup to nuts. So he basically knows everything there is to know about renewable energy development. And his primary focus has been on hospitality. So he's basically has hotel projects are his bread and butter. And he'll be talking more about opportunities in battery storage, again, with a focus on that. Our second speaker today is Scott Ameduri, the president of Enerlogics. They're a solar and storage developer who's basically has 20 years of experience in project development with a focus on energy efficiency, demand response, and development of energy projects, including solar, storage, and wind. And lastly, Jonas Villalba will be closing us out. He's the Chief Innovation Officer of Molecule Systems. He's also the CEO of Energy Boom. Jonas and Molecule is a technology software development platform, an energy management solution serving the needs of industrial customers and basically all kinds of energy applications. Molecule is one of GridVest's preferred energy management solutions, and we're really happy to have Jonas and Molecule on board here. So with that, Dan, I'm going to hand it over to you to talk us through opportunities in battery storage with a focus on hotels and hospitality. But really, I think what people want to know is, what are all of the learning, not all, some of the learnings, the key learnings that you've had through your journey here in battery storage, and how can we take those and be fruitful and multiply.
Sounds good. Thanks for having me. You want to jump in with the next slide? You'll have all the knowledge that 7 minutes can offer. This is 2 hotels side by side that we worked on. This is rooftop and carport to give you a sense of the scale of a typical project. This is in Carlsbad, California. Take your kids there to Legoland. Next slide, please. This is what we do. Behind the meter, we do 25-year agreements. We used to call them PPAs. Now we call them energy services agreements. Every one of my projects has had batteries to date, and many of them have backup power microgrids. Next slide, please. I would characterize our current operating environment as a tale of 2 cities. Charles Dickens, right? Didn't he write about Christmas? So it's appropriate. So we have the best of times and the worst of times. In California, it is going backward. On NEM3, many of us are painfully aware. We are getting basically nothing for exports. That's a big change from NEM 1.0, where you got dollar for dollar on all your exports. And so the attachment rate for batteries on NEM 3 projects is somewhere around 90%, I heard. It doesn't surprise me. If you're not paid to export at all, you need to do solar self-consumption, which means you need energy storage. And batteries to date, in particular, lithium iron phosphate batteries have been the cheapest form of storage that we've encountered. The other thing that California has done, I mean, I could talk for an hour about nasty things that California has done to destroy the solar market, but a big one affecting our business is prevailing wage requirements are basically required for every new project moving forward, which means you're paying, folks carrying boxes, maybe $50 an hour, to carry a box around. So it's becoming expensive. Next slide. So that's the bad news. The good news is the feds have been taking giant strides forward under Biden. I would say that's likely to continue under Trump with some tweaks. I'll talk about that a little bit. But basically, you've gone from a 30% investor tax credit to, in most of my jurisdictions, a 50% ITC possibility, and sometimes even more. That means they're paying for more than half of your project costs, whatever the tax basis is, in a tax credit. And the other thing they did is they made that transferable for cash. So it's a huge benefit. Depreciation comes on top of that. The work I do as a developer is eligible to be included in that tax basis. So when you add up all of these federal benefits, it can essentially pay for the entire project. And there's a lot of flexibility in what your taxable basis is in terms of how much you pay your installers. So there's ability to impact those tax credits. Why I think it will stay is that 80% of the money is going into Republican districts. You saw that slide Alex put up on Texas being the fastest growing battery market. Also, these projects tend to be owned by wealthy people that the Trump administration tends to like. We're talking, the Blackstones and Goldman Sachs's of the world. So I think if they try to mess with the benefits too much, there will be some opposition. But what we are hearing is that the continuation of the ITC credits will likely hinge on domestic content much more than it does today. So start gearing up with some US supplies on panels, inverters, and hopefully eventually batteries someday. Next slide, please. I'm going to talk about 3 opportunities that I'm seeing in the C&I market. Number one, big opportunity is fleet electrification. As Alex mentioned, many people are ordering new EVs like drayage trucks, trash trucks, and they have no means to charge them. Then they go to their local utility who tells them one of 2 things. Number one, it'll take 3 years to provide power. And or number 2, that 300 kVA transformer, yeah, we're not going to give you that. We'll give you 150. They're giving inadequate service upgrades or taking too long. And that's where we come in. We can bridge that gap to fleet electrification. And in particular with batteries, just to put a sense of size on it, the max demand at one of my hotels might be 150 kilowatts. That's instantaneous demand at any given moment. One fast charger wants 150 kW. The grid is just not meant to handle this. And so batteries need to fill that gap to supply that power need. And they can trickle charge at night when demand is lower. To put a size on this, you're talking about 500,000 vehicles just in California subject to electrification in the near term. It's about a $500 billion opportunity. And none of these people, very few of these fleet owners have any idea how to provide this energy. So next slide. Big opportunity 2 that I see is DC microgrids. And it's related to my first point. Solar is DC, batteries are DC, and now cars are DC with batteries in them. That means if you can generate, store, and distribute your energy in DC, you control that world. Whereas utilities and the grid is all an AC world. So as long as you find projects that have good real estate, places to put panels, places to put batteries, we're encouraging the use of DC microgrids so that you keep everything in DC and your only connection to the AC grid world is your battery inverter that is trickle charging the batteries, say at night, as much as it can. So that's a big opportunity for project developers. And the last big opportunity I'm exploring, I've got active projects in, next slide, please, is repowering old projects. So the recapture period on tax benefits federally, this means every state in which we operate, is a 5-year recapture period for the ITC and the bonus depreciation. After that 5-year period, you can repower a project and you get a brand new project with brand new investor tax credits, brand new depreciation. So the sweet spot is a project that's 5 to say 15 years old from its permission to operate date. Go in there, put in new panels, new inverters, and create whole new ITCs. And the benefit of that is it's like 10 times easier to do a project like that than it is to do a greenfield project. There's no digging. There's no, oh my God, the conduit can't fit in the cement correctly. There's no problems because it's already built. You leave the conduits and the wire, but you're just pulling down panels and inverters and putting up new. You must obey this 80-20 rule where you have to replace 80% of the value. But beyond that, this is a very fertile field to operate in because it is, you don't need to mess with the interconnection agreement. as long as you're not changing the size too much. So it's a quick way to get more revenue on a very predictable project. Last slide, please. So I'm very bullish on the market. I don't think the ITCs will change a lot. This is a project I'm working on right now. It's about a $4.5 million project, solar batteries, EV chargers, a microgrid. It will have a 50% ITC. It's in San Diego County. The whole county is a energy community. You know, I will probably make back my entire investment without even factoring in the annual revenues from the off-taker. So this is a really lucrative one. My plan going into this is to sell the project. But if I don't get a good price when I sell it, I'll keep it and transfer the ITC for cash. And the ITC is 50% of the project. So I'll get 50% of the project cost back-ish. I mean, it trades a little bit of a discount. And you can borrow against those future cash flow streams so that you have very little equity in the deal, and the money just keeps coming in for 25 years. I think that's it, except there might be one more slide talking about GridVest. So I see GridVest's role as crucial for getting these projects done. My battery suppliers require 30% down payment, and it takes 4 months minimum for the batteries to arrive. It's just a wonderful option to have. In the meantime, I can sell the project, right? I don't have to put 30% of my money up front in my situation. So I'd encourage you to speak with Alex and their team and see what the latest borrowing rates are. But this has been a void for a long time in this marketplace, and I'm glad GridVest is here.
Amazing, Dan. Thank you for that and awesome learnings and sharing your project there. And look, you basically kept to the time, which is amazing.
Astounding.
And but thank you so much again. And we just appreciate all you do in that market and all the willingness to share your work. And I know that you've got a good eye for quality and for navigating challenging permitting and project dynamics. So thanks for all you do, and appreciate your sharing. And I've got a lot of questions, and people have a lot of questions in the chat here that I'm going to ask you in the fireside chat portion. But just in the interest of time, I'm going to move on to Scott here, Scott Ameduri, president of Enerlogics, to share a little bit more about his projects at the schools in California, navigating district state architects, project economics and financing. And yeah, Scott, so I'll hand it off to you to take it from here.
Great. Thanks, Alex. Good morning, good afternoon to everybody. We can go to the next slide. Again, just a little bit about who we are. We are a developer of distributed energy solutions that increasingly include solar energy storage, EV charging, microgrid, and even prime power solutions. Our approach is, like everybody else, to utilize generally off-the-shelf kind of systems, but combine them in a way that ends up with a unique situation or a unique solution for everyone's specific customer needs. Next slide. Again, as we focus in on energy storage, and we operate across the country, so this will kind of give you a flavor of what happens in the market. We see a number of use cases that kind of go into the value stacking for what batteries can be used for. And importantly, these are dependent on a whole set of policies, whether it's the ISO or the RTO that you're in, the state utility, and the tariff that you're actually on, or a facility is actually on. All those really impact the ability to tap into these different use cases or different values streams for a battery system. Again, we kind of focus in on 3 big areas. One is on cost savings. In California, that's increasingly time of use arbitrage and demand charge reduction. In other areas, it's that have less time of use, it's mostly about demand charge reduction. So areas that have high demand charges and facilities that have relatively peaky demand give us the ability to really mitigate that impact. As we look at markets like PJM, we're looking at 5 CP and 1 CP kind of contributions on the capacity side and reducing capacity cost for customers. Second big area we look at is resiliency and power quality. We're seeing more and more, in particular, industrial facilities where Power quality is an issue where they're having either outages, short blips, you name it, and the rework associated with that is material to their operations. And being able to solve for that from a power quality and a resiliency perspective is very material. Again, also, as we look at California, the PSPS has been a big driver on why we see more battery storage systems in the resiliency market. And again, in certain jurisdictions, such as PJM and MISO, we actually can generate revenue from the battery system. So we're looking at things like demand response, frequency regulation, ancillary services, et cetera, that can actually generate revenue from that battery system to help that battery system pay for itself. And again, it really depends on where the location's at, but all of those can come into play. Next slide. We're going to dive into a project we're doing for Palmdale School District in California. It's a 5-site portfolio of existing NEM1 solar being paired in with now new energy storage systems on that. All of these projects are developed with incentives that were under the SGIP program to help those schools have resiliency and do arbitrage and peak load management. The big challenge that we have on this one is the district's milestone payments lag delivering equipment deposits, like everyone else has talked about. Having long lead deposits on long lead orders gets to be a challenge as a developer to be able to match up the payment terms from the customer relative to when payments or dollars are actually going out the door. Unique about California is that there is a division of state architect that has review of all school related projects. So that's been its own set of challenges that we'll talk about on the next slide. Within the California DSA, they are requiring a whole number of things that go into systems. Basically, it requires large-scale fire testing in addition to UL 9540A. If we go over 600 kilowatt hours of a system, we found some ways to get around that. We'll talk about a bit more. Additionally, DSA requires the certifications not just to be, say, UL 9540, but it has to be from a nationally recognized test lab. And we worked with GridVest and our battery supplier SYL to make sure that all of that was done in a way that was consistent with what DSA was looking for. Again, for this system or for these schools, we used SYL Energy Storage System. SYL is soon going to be rebranded Ryzen Energy, but SYL has a great system. But we did have some challenges with them in that midway through our design and engineering, SYL switched their inverter models to a higher voltage model that kind of redesigned the DC block sizes. Next slide. As an example, Sage Academy is one of the deployments. It's over 600 kilowatt hours. It's the 1147 kilowatt hour system. But the way we did this was to basically split the system in half and separate those two sets of 600 kilowatt hour building blocks by 10-foot minimum separation. So as you kind of look at the top picture or the bottom diagram, the crosshatched areas are the battery cabinets. There's two cabinets that are basically bookends, if you will, on the pad. And in between are the inverters, battery combiner cabinets, EMS, et cetera. So that we're able to meet DSA's requirements for the system without having to do the large scale fire testing of each and every kind of configuration of the system. Next slide. Through GridVest, again, we worked closly with Alex and the GridVest team to help us get an MSA in place with reduced pricing compared to what we had an additional quote. Again, GridVest very much helped us match the payment timing relative to equipment deposits and things like that. That was lagging when we're actually, or leading when we're actually getting the payments from the customer. GridVest helped with the factory acceptance testing. Again, our first kind of rodeo with SYL, we wanted to make sure we had on-site observers for that to ensure that everything was performing as expected before it got here. Once it gets to the stateside, we do have some delays as we're installing everything else. So GridVest was able to help us with warehousing and coordinating the delivery of that system as well. Next slide. I'll go back one. I think I'll just echo one more thing that Dan said. We are seeing electrification as being a big demand in the marketplace, not just electrification of buildings, but the fleet EV applications are becoming a challenge, not just in California. We have customers that are doing it in Chicago and New York City and other areas. So fleet electrification, particularly Class 6 through Class 8 trucks, is going to be a challenge. We have, just as Dan alluded to, one facility that was planning on deploying as many as 20 Class 8 electric trucks a day one, and the utility said, sorry, 3 to 5 years before we can do the upgrades. So having battery systems to act as a electron gas tank is very material for these systems. And we echo the DC microgrids is sort of one of the next technologies that we're looking at as well, to see where things are headed.
Amazing. Dan and Scott, you guys have both enlightened us. Thank you, Scott. That was awesome. That really just a testament to your dedication getting through the DSA process. We were alongside you, and we know how challenging that was. So congrats on that. And again, anyone out there who's doing public projects in California, you definitely want to talk to Scott. He's been through it. So thank you again. And now for our final speaker, before we move into the fireside chat portion, Jonas Villalba, who will be talking us through energy management systems and the importance of EMS, common pitfalls that occur regarding energy management systems, and some examples. So thanks, Jonas, for being here. Really appreciate your expertise, and happy to hand it off to you. And just a reminder to unmute yourself.
Thank you, Alex. Appreciate the opportunity. First slide, please. Hello, everybody. My name is Jonas Villalba. So I'm as introduced, the CIO at Molecule Systems. We have a unique platform developed and create a bunch of value stream opportunities in the form of applications. And one of the applications I'm discussing today is our EMS, or Energy Management System application. And it's an exciting technology and solution that I've been deploying on different projects in the space. Essentially, it's a very flexible EMS that can integrate with any device via Modbus. And so we deploy that application on any Linux-based microprocessor. And so I've deployed it on a really powerful site controller and integrated into different projects. And so it's protocol agnostic and can communicate with a whole number of different typical technologies that you'll see on different microgrid solutions. So we deploy the project, the site controller, and so it can talk to generators on site, or all the different PV inverters and basically any battery technology that you come in contact. So my job when I approach these projects is to sort of solve the riddle, if you will. Customers will say, my desired outcome on a project is to do X, Y, or Z, and I help folks sort of solve the riddle on how to deliver that outcome. And so the Molecule EMS is the tool we use to solve that riddle. And that usually happens in the form of cost savings, or behind the meter solutions, and also in front of the meter solutions. And so the MOS EMS is how we get that done. So next slide, please. The way we do that, there's different optimization opportunities. Includes time of use. So for behind the meter optimization, obviously optimizing, so cost savings would be demand, charge savings, time of use savings, energy arbitrage, PV self-consumption. When I look at projects in the Midwest that they look a lot like our NEM 3.0, they're not getting really any financial benefits for exporting. So self-consumption is huge. And so we can essentially set the EMS to control the battery for any market in any situation. In addition to controlling the battery itself, it also has the ability to control external circuits in the form of contact. Again, anything with the Modbus control. So we do load control circuits and reacting to the incoming load at the utility. And so by being able to do that, we can set priorities for if the facility hits a certain demand level, then the battery can discharge. But not only can the battery discharge, but if the facility hits a certain demand level, instead of just discharging the battery, we can actually shut off loads. And then you can set the priority for if you want to control the loads as first priority, and then do the battery discharge as a second priority, and vice versa, and then change that seasonally. So the cool thing is the world is your oyster, and you can literally set up any outcome for a facility in a drag and drop scenario. So a lot of flexibility there. Next slide, please. In addition to the on-grid optimization, there's also the off-grid optimization. I think that's where a lot of the complexities come into place. And in the off-grid optimization, there's the integration with the automatic transfer switches, or disconnect switches. A lot of people are using SCL relays and whatnot. And so integrating the EMS with the off-grid scenarios has been a good challenge. And so I'll give you an example there. In front of the meter, having the batteries integrate with outside programs with demand response and VPP is another optimization that we're integrated with different programs like LEAP and whatnot. Next slide, please. This is a use case example, very interesting one. So we inherited a project that had an automatic transfer switch, and they were using the transfer switch to island off of the project in the resiliency scenario. And so the transfer switch needed voltage on the emergency side to disconnect, and had no way to do it. Actually, they had a car battery trying to create a false voltage. So it wasn't working. So basically, we took the site controller and we used a GPIO to force a low voltage on contactors. And so when the grid was on, we would allow the battery to pass through the central loads panel directly. And then when the grid went off, the red contactor would open automatically with a loss of voltage, and then the site controller would hold close the green contactor, and we would send the power to the emergency side of the automatic transfer switch and send the power right back to the same essential loads panel. And so we use this natural state to essentially do the exact same thing, but it was a much better solution than using a car battery. Next slide, please. This looks like a bunch of lines, but in actuality, this is what it looked like for real. So this was essentially the two contactor state, the site controller in the middle. And so it was just a much more elegant way to solve the same problem. And it was a total win for the project. So a lot of details and complexities in there, but a very cool solution. So I'll leave it there. I can answer a bunch of questions, but like I said, you can solve pretty much any riddle with a flexible EMS, and that's basically what I do.
Amazing. Thank you, Jonas. Great insights. And yeah, it just, I think, goes to show the complexity of the EMS side of the equation, and the value add as well. I think if you don't have a good EMS, basically you don't really have that good battery storage system. So yeah, it's great. I think we've gotten a ton of questions already. Some of the panelists have jumped in and answered them right away. So thank you for that. We've got some good details in there. But I wanted to just kick things off with a bit of a fireside chat, and then we can continue to answer questions. So please do drop your questions in the chat. We will get to them. And just to kind of kick things off, going back maybe to Dan, since you started us today, what do you after hearing the presentations so far, what do you think is what haven't we said that is basically, and maybe is something that's the missing part of battery storage, that either it could be just like, what do you think, and thinking about 2025, obviously there's a lot of uncertainty coming with the political situation. What do you think is on your mind that you wanted to share with people? I don't know. I feel like it's a vague question, but I feel like you might have some magical insight for us.
I don't know how magical my insight is. I would say that uh, the grid is constrained. That's the overarching theme between your comments, Scott's comments, my comments, and to a lesser extent, Jonas's. Uh, and we need the storage. And right now, the storage comes almost entirely from China, right? And so there is a tension, right? We are trying to build up our LFP capabilities in the United States, but so far we don't have it, and we're a couple years away. The Chinese have decades of, LFP started in the United States, but we just lost it, and it, went to China and they perfected it to a large degree. So I am concerned about tensions, but I think Trump being Trump is going to do an all of the above on energy, right? He wants to be the biggest and the best, and we don't want to lose an AI race, a global race. So I'm very bullish on these batteries. I think the US will gradually build up some supply. I know some very small suppliers of batteries, but that is a systemic risk, is we get all this stuff from one country primarily.
Yeah.
And I don't, we don't need to pontificate about it. We just need to adapt, right? And figure out a way to provide the storage, because the storage is key. That's why I got into energy storage, because it's, renewable power is fabulous. It's clean, it's cheap, it's all these wonderful things, but it is intermittent. And
Yeah.
so you just got to have these batteries, and we don't have them in the United States. So I think that's one thing.
Great point. Great point, Dan. Thank you for that. And now to you, Scott, question for you. So talking about ROI on these projects, and and Dan and Jonas, feel free to jump in as well. But what do you guys think? And Scott, I'll start with you. But what do you think? What are you seeing are the biggest ways to make the economics work for a commercial or industrial user? So thinking about what's going to move the needle, especially. I think it's especially important if, depending on what happens with tariffs and things like that, if the cost of battery storage is going up in 2025, which we expect it probably will in some degree, how do you almost double down on the savings to really optimize? What are you seeing?
Yeah, I mean, we're seeing, again, in California markets, I think the high cost of electricity and the low export value under NEM 3 really drives a consideration of how you optimize around a mix of solar and storage to best serve a customer's needs from an economic perspective. We are seeing a lot of customers where ESG goals are very material for them. Particularly European and Asian owned companies being able to hit those ESG goals mean they want to hit more and more of their consumption with on-site renewable energy. So that's one area we see that driver on it. In terms of energy costs and demand charges, they aren't going away. Every utility we see across the country has an increase in both energy and demand costs that are now driving the cost effectiveness of storage more and more. In particular, kind of echoing what Dan said, solar as an intermittent resource means that I can't reliably hit demand charge management with solar alone. I need a dispatchable service, whether that's curtailment on the facility side or whether that's a battery system that really kind of helps us address those demand charges. And we're seeing that, from not just large industrial manufacturing, commercial office buildings, but even the municipalities and co-ops in particularly in the Midwest are hitting with this large capacity and demand charges that they want to mitigate as well. So again, we really look at kind of those as the big ones. I think the wild card for markets like PJM is looking at the revenue opportunities. Historically, we can look back and see what frequency regulation values are, but it's not a guaranteed price on a forward basis. So that is one thing. But again, the PJM capacity auction says capacity prices are going to go up. So it is material for everybody.
Yeah. Jonas, I'd love to get your take on that from like an EMS perspective, right? In terms of optimizing economics.
Yeah.
do you concur with what Scott said, and do you see any other areas that maybe on the future, like whether it's
I
VPPs or other related, actual like kind of needle movers?
I do. So the I think I wouldn't say the equation's simple, but the equation's simple. It's actually really complicated, but I say gone are the days where you look at how many kilowatt hours somebody consumed last year and try and get that many kilowatt hours out of a roof. And I think that a lot of people are still using that metric when they design a renewable energy system for a customer. Bottom line is you look at how they consume energy, and you look at how the utility charges them for that energy. The reality is a demand charge only is offsettable if they charge it to you in a peak window. If there's a 5 hour peak window, then the battery can offer value during that peak window. If you're in a Midwest market and the demand charge is 24 hours a day, the battery's not going to do a hill of beans, because battery's not going to offset the demand window that long. That said, in that same market, if you have a zero export, then you need to model your EMS to make sure that you self-consume the heck out of that PV. And so, like I said, like the Midwest looks like NEM 3.0, and you don't sell that PV system for demand mitigation, you sell that PV system for self-consumption. And so I can tell you that, 50% in my opinion, 50% of the folks selling these systems are theoretically, I don't even know that there's a lot of like solar modeling tools that help folks sort of dial in how to design and propose a system where you need zero exportation. And just because you could fit 150 kilowatt on the roof, if you're exporting 25% of that power to the utility and getting no credit for it, that should be a 500 kilowatt hour battery that you're self-consuming if the customer is consuming 25% of its power after 6 p.m. And so you've got to look at the consumption profile of the customer and make sure that they're not losing 25% of the value of the solar on the roof, or you need to reduce the system size by 25%. Either or, and so there's a lot of mal designs going out, or improperly sized batteries based on the tariff.
Amazing. Well, thanks for that. I think it makes a lot of sense. And we need more optimizations, and ideally those integrations. But and again, I'm personally excited about the future of virtual power plants and other utility programs to incentivize and take advantage of battery storage systems. Dan, just a question now, we're still talking kind of finances. How about PPAs? Can you tell us a little bit more about what you're seeing in the world of PPAs with combining solar and storage? Is there anything unique in ways, in how to do that? Obviously, given the mismatch in timeline of the life cycle of a solar and a battery storage project, as well as the difference in, kilowatts and kilowatt hours. What are you seeing in terms of, for those who are looking for PPAs, what should they be seeing?
It's still very popular. When I sell so I keep about half of my projects and sell about half of them, and I do energy services agreements, longer term ones. I have opted for the keep it simple, stupid approach on these, and I attach the battery value to the PPA or the ESA price per kilowatt hour. And that has pros and cons. The biggest pro is it's simple, and the guys that buy these projects want a very simple number. How much solar happens, and I get whatever, 20 cents a kilowatt hour. It's very predictable. Whereas the other way, there are other ways you could do it. You could lease the battery. You could do a shared savings agreement, which I did in the past, which makes more sense a shared savings agreement with the battery, it's just harder for people to get their heads around. And it's like, oh, well, we missed the savings this month. Well, whose fault was it? Was it the technology broke? Was it someone at the hotel, you know, unplugged the router by mistake and it couldn't control the system? Or did, you know, PG&E change its tariff? So a shared savings makes the most sense, but it just in practice has been really hard for me to implement. And a lease is just straight up cash, which is nice, but better to have a higher per kilowatt hour price and sustain that savings for your customer by providing those demand response and demand charge management and time of use shifting. And Scott does some other really cool stuff that I haven't done. Frequency regulation, we don't really have that in my markets. There's constant new revenue streams that batteries can bring. Better to just have a high price per kilowatt hour, and that sets a high purchase price for your project. But then the onus is on you to make sure those batteries are working to deliver the savings that the customer needs to, you know, make other recommendations to their friends.
Do you have any ballpark kind of return IRR type internal, you know, not for you, but for the customer in terms of the economic savings that, you know, they might expect on a just.
Yeah, and I think Jonas hit on this as well. So the only meaningful way to address demand charges is with batteries. But then the only demand charge that you can attack well is that peak demand charge, you know, from 4 to 9 p.m. in California. So you're going to be stuck with some demand charges in most of your markets. And so for my customers, hotels, their bills going in to my projects might be 60% demand charge. So, you know, in theory, I should be able to save them a ton of money with solar and batteries, but in reality, they're always going to be stuck with a demand charge and they're always going to be stuck with a non-bypassable charge. So the best I can do is to save maybe 10 or 20% off of what they're paying today. But the real beauty of our projects is the avoided cost. PG&E, SDG&E, SCE are raising costs 15% per year on business customers with no end in sight. And that's a generalization, but it's double digits across the board. Not going to change anytime soon for all the reasons we discussed. Fleet electrification, building electrification. The average age of a transformer on the grid is at end of life. So they have to replace all the ones they got, plus add all the new ones to handle all this electrification. So rates are going up and up. Wildfire risk is going up. There's no way that rates are going down. So they're going to save a little bit today, 10, 15, best case, 20% off of what they're paying today. But then each year on a compounding basis, they're going to be avoiding those 10%, 15%, whatever it is, costs. And it's a shame the tax equity guys that buy these projects will only say, oh, well, we'll give you a 5% escalator in our model. It's like, no way. It's going to be way more than that.
Yeah.
The historic was, I mean, 3%.
So on that note, what do you guys think of the value of resiliency? Because I think the next piece is, you know, how much do you value backup power and having electricity when the grid goes down? Anyone seeing more demand for that, more decision making from that, or even some more economically motivated calculations, at least based on that? Because that's something I've always felt has been a missing part of the equation.
Yeah, well, let me backtrack for a second on the prior question. I think the other thing that's important for particularly public sector clients, but it hits private sector as well, under the PPA model, having price predictability is important. Some of these people just want to know what their costs are going to be and not be subject to that 10, 20% rate increase, right? So having a fixed budget for a public sector school or university, just having stability on, you know, some or all of their energy costs is very, very important and very material for them. So again, it bodes well for the PPA approach or the energy services agreements approach, and that's really one of the drivers we see even in the Midwest. You know, seeing 10, 20% rate increases is something no one can budget for that. They don't know what's coming until it comes. And frankly, you know, most of them aren't energy experts. They are just looking at that as a line item on their budget. To your second question around resiliency, I think the discussion I had yesterday with an industrial, I think industrial manufacturers really have a very good handle on frequency of outages and what rework cost might be. This was a facility in West Virginia that literally said it's costing them on the order of $80,000 to $90,000 a year to have that outage once a month, just in rework time and rework costs and things like that on what they were making. That's pretty rare that somebody has a good characterization of it, but everybody knows there is a challenge to interrupting operations in, say, an industrial environment. In commercial environments, I think it gets a little different, right? Is there a true cost of an outage when your building has a blip for a minute, 5 minutes, 10 minutes? Maybe there is, maybe there's not, particularly in other areas. Hotels are probably a very different story. I think, it's a convenience function that probably hits their bottom line and their top line on what they've got to do when there is a power outage. But I'll let Jonas or Dan continue more.
I think that the market probably doesn't understand necessarily the complexity of the resiliency in a lot of cases, and so they'd say, here's a 250 kilowatt hour battery. Do you want resiliency? Yeah, sure. Let's add that. And meanwhile, if you've got a resiliency on a 400 amp panel and it's got a whole bunch of non-resilient loads on that panel, the complexity of backing up a 400 amp panel gets quite pricey, and so the project just turned a lot more expensive. And then educating the customer as to like what you're actually going to back up needs to happen early, and it has an adverse effect on the ROI. So resiliency is like, I think you asked the value of resiliency. The value of the resiliency comes in if I'm offering resiliency because you're backing up a panel that's I'm backing up a panel that's backing up a freezer that's freezing human tissue, and if that human tissue goes bad, then I lose $1 million. That's ROI and resiliency. If I'm backing up resiliency for the heck of it, there's no resiliency often throws the ROI upside down because it's complex and expensive. And so it needs to be known up front and discussed that it adds complexity. Sorry to be a Debbie Downer.
You ever see no, do you see technology at any point in the near future stepping in to solve for that?
I think
somehow I know there's just at some point it's just electrons and building codes and but it seems like from the outside perspective, right? There should be an easier way to do backup power theoretically.
I think that I think hybrid inverters are offering some solutions there, but they too have their own sort of they're way more expensive, and they offer complexities in and of themselves. But so like it's I would say that non backup projects cost X and backup projects cost X plus Y. And at the end of the day, it sort of is what it is, and some projects need it and some projects don't. And so it's something that needs to be communicated to the customer, and if you're doing it for compliance, then you do it when you need it. And so I haven't seen a single resiliency project that wasn't complex for one reason or another, and you work through it and you get them done, and they're completely doable. They just always have a list of certain boxes that need to be checked. You check through them, you get them taken care of, and so. But I've also seen a lot of projects that didn't that you learn the hard way, and people don't have them in the budget, and there's a lot of angry customers because it always costs more than they expected.
Got it.
Yeah.
Well,
I think
a quick
quick
comment on resiliency. They tug in opposite directions, right? If you have a battery and you can either do resiliency or economic savings, somebody needs to make a decision about how much battery to reserve at all time for an outage. And if you don't have that capacity available for daily cycling, time of use, or demand charge management or demand response, you're missing out on economic savings. So, if you ask a customer, like Jonas said, do you want backup power or do you want bill savings? 99% of them will say both, but that's not good enough. You need to specify the relative value of those things, because someone's going to say the reserve ratio is 20% of the battery or 50% of the battery or something like that. And that has implications for how long you'll have resiliency in terms of hours. And maybe you'll miss out on your cycling requirements for your S-chip rebate or something because you're not cycling the battery enough because you have too much reserve for backup event. It is a complex thing. For some reason, we have it for resi. You can take your Solarc inverter, stick it on your 200 amp service, plug your generator in, plug your grid in, plug your battery in, plug your panels in, boom, microgrid in a box. We do not have that for commercial. It just doesn't exist. They're trying, they're not there yet. You're always integrating like maybe a generator on site that's big and can't talk to the thing, or you're integrating a giant switch gear that is very difficult, to do. So I don't know why it's so hard, but it's wicked hard. And I got spanked badly by my first backup power project where I agreed because I didn't know what I was getting into to back up elevators in a hotel. Well, elevators have their own things, not just for backing them up with power, but they need shunt trips in them that respond to different sensors, from heat sensors or smoke detectors, etc. You need different panel boards that accept shunt trippable breaker. It's a nightmare. It would have been easier to just back up the entire hotel.
Yeah, I'm going to segue off that. I think one important point here is when you're looking at resiliency, full building, full load backup is really, really expensive. Getting a customer or a facility manager to identify critical circuits is very important to that, because right sizing batteries for resiliency is the make or break on it. That's I guess I'd say the art of it. But going in and saying, hey, they've got a 200 kW peak demand and we're going to back up every single load is extremely expensive. And that's a material driver on economics. So as Jonas pointed out in his slides, with essential and non-essential loads, that is critical to identify that separation when we look at being able to provide resiliency, particularly for long duration outages.
Yeah, totally agree. I think that is crucial, right? And it essentially optimizes the system that you do have, right? When you can, you basically are picking and choosing the important critical loads. You make what you have go a lot further. And so amazing stuff. I'm going to transition now into questions from the audience. We've already answered a number of them. We've gotten 23 questions so far, and the panelists have done a great job of jumping in and replying via chat. There are a couple that I'm going to throw out to the to just discuss further. And first, just question is, roughly what size, there was a question about the size of behind the meter energy storage varies from under 100 kilowatts to 10 megawatt hours, excuse me. What size are you seeing as the most growth in? Scott mentioned basically deployments in the 500 kilowatt hour to 1 megawatt hour range. And then some small commercial under 100 kilowatt hours. Do you guys concur with that, Dan and Jonas? Is that about what you're seeing in terms of the average size?
I would say that Alex, I think you have a very cost-effective product that guides. Like if I'm looking at a project and you've got a cost-effective product that comes in a 250, 500, or 1.2 megawatt hour size frame, I pretty much go 500 or 1.2 megawatt hour now, because it's just it's almost a no-brainer. It's just cost effective, and it comes with all the bells and whistles. It comes with commissioning, it comes with everything. So I basically Lego block that into most projects now. And I use that for non-resiliency projects, and then I use other, more expensive batteries for resiliency projects. So I think my advice is find a good resiliency solution. They're going to be a higher price per kilowatt hour. And like I said, if you need the resiliency, it's a different animal. If you don't need resiliency, look at a very cost-effective, higher kilowatt hour battery that allows you to maximize self-consumption. And because it includes that EMS and like Dan blew me away with his capital stack and the know your capital stack and understand, the maximize that the ITC, the energy community, and demonstrate the ROI from that perspective, and your close rate will increase exponentially. You can do that. It's a game changer.
Yeah.
Yeah.
Great. Yeah, totally. Great answer. So just moving on quickly, just in the interest of time. There's a question about the DC microgrids. I know, Dan, you wrote kind of a white paper on this, but does anyone have any experience or additional resources or just projections of what the future of DC microgrids are? And I know, Dan, you mentioned this in your slides as well as one of your future kind of opportunities, and I believe strongly in it as well. What's your take? Like, and what's the group's take in terms of like, are these? Have you guys, anyone else seen other examples of this?
I saw somebody at RE Plus. I can't remember who it was, but there was a couple of DC microgrids being demonstrated at RE Plus last year as well. It's definitely coming. I think it's really a way to, as Dan said, kind of avoid the AC problem, let you interconnect a lot more stuff behind the meter, not run up against all the limitations under electrical code and things like that. But it also, more importantly, reduces the burden on the utility, of which we know is a constraint right now. So we see it coming more and more, but it is probably not well understood enough by most engineers or utilities to deploy across the country. I think the California utilities are definitely going to understand it a lot better, a lot faster.
It starts to make site selection more important to me. So most bean counters look at a PPA and energy services agreement, and they just look at dollars per kilowatt hour kind of situation. They don't think about the other value in the project, which to me, I place equal value on the lease. I have a 25-year legal right to occupy that space. Well, if I have more land under my agreement, I can add solar, add batteries over time as electric vehicle adoption grows. So I sat down with the guy yesterday morning who owns 6 hotels. And I said to him, what percentage of the vehicles parked on this lot are going to be electric in the next 10 years? And we looked at each other and we're like, 100%. So now, whether people don't drive anymore and it's just autonomous vehicles and nobody parks anymore, I don't know. But there will be electric cars roaming around somewhere, and we will have the means to charge them, and we will be able to do that on our construction costs, not on PG&E, SDG&E's, rates that they make us take.
Well said. In terms of, I think this is a question that a lot of people are asking is what do you see as the future of navigating tariffs, right? So in navigating potential changes to IRA and navigating all this uncertainty, right, which we could speculate all day long about what will happen. Today it's December 20th today, right? We're about to go through a few weeks of holiday, and then we're going to come back to a new world. What do you guys, how do you suggest for the people on this webinar to kind of look beyond the noise and look more like at the fundamentals? Like, what's your advice for how to navigate the uncertainty and navigate the changes, right? Because I mean, roughly you could wait and see, you could act and get ahead of the curve, You could panic and cancel everything. I mean, what are the, you know, what would you do? And what's your general advice? Because obviously it's hard to give much specifics without knowing the future.
I would say our field is incredibly complex. You know, you need to know a little bit about construction, a little bit about chemistry, a little bit about finance, legal, tax, and all these things are changing. Electrical code. No one person can be an expert in all these areas. And I was listening to Revenge of the Tipping Point just as an audiobook on my long drive yesterday. He talked about the cheetah almost being wiped out because they have no genetic diversity. And so we need to build teams, you know, whether it's physical employees who work together or just loose collaborations like, you know, Scott, Jonas, me, you, Alex, just like people that have one part of the picture where they can go deep. When solar was on NEM1 and you could just put a panel up and wind a meter backward and save the customer dollar for dollar, like it was so easy to understand and so easy to make money. We're just not in that world anymore. You need to have batteries and you need very good controls. And no one person, I would argue even Jonas has a hard time unlocking all of the values. Very few EMS providers understand backup power. They're just focused on that bill savings component. Like STEM, the market leader in commercial batteries, they didn't even do backup power. Jelly, where I work, we didn't touch it. We were like, no, we don't want to do it unless someone twists our arm. So to be able to understand all those tariffs, how they change, the adaptability over time, you need subject matter experts either in your employ or on your speed dial for, you know, getting these projects done.
Yeah.
I think Daniel, I think your team approach is very important. I think the other thing to consider here is that this has been a fluid market. We've dealt with ACCVD on the solar side and the tariff impact on that side of it. Frankly, as much as we all love the technology, this is always going to be a financial sale. So being able to navigate different supply chain risks, different supply chain tariff risks, who's got indemnification of that, et cetera, is part of what goes into the decision process. Frankly, I think the idea of running scared and putting everything on hold because something might happen is probably not the right approach. But there's also don't go so aggressive that you are selling projects that you can't actually support. So again, I think our approach has been, be cautiously optimistic that maybe tariffs won't come in so bad. We think there's going to be a disruption in the market for probably a 12 to 18 month period. But it doesn't appear that there's going to be any slowdown in the domestic manufacturing. It's going to be a matter of how long it takes to get all that stood up, and maybe it gets accelerated. But for sure, I think what we're going to see is more and more things like we're seeing in the PV world, where people are onshoring more and more manufacturing or nearshoring more and more manufacturing. I think that's going to happen in the energy storage space as well.
Yep. Well said. Jonas, any final thoughts on that? Otherwise, I'll move on to the next question. Just want to give you a chance in case you had anything to add.
No, I think those are great answers.
Great. So there's a question about one was about hotel projects that are BESS only. So basically, you look what are you guys seeing for and not just hotels, but any kind of project that's battery storage only without solar. And also the other question is, what about space constrained locations? There's whether it's a hotel or we've looked at grocery stores, when you don't have a lot of footprint, what is, how do you navigate that? And, are indoor solutions something that could be considered in a commercial scale space? So there's three questions in that.
Yeah, that's three questions. I'll go quick. Indoor is becoming virtually impossible here due to increasing scrutiny on fire codes. I don't know what it's like in Missouri. Maybe you can stick it in the basement, no problem. Here, you get into all kinds of nasty fire codes. So I don't even go there. Interestingly, in space-constrained areas like supermarkets, I am seeing some creative solutions. One company that's quite interesting is Yada, which integrates on the roof. I have not purchased it yet, but I'm intrigued to check it out and try one. batteries take up a lot less room than solar. The issue is there's all sorts of constraints, especially Scott is familiar with this for public schools. Can't be under a carport, can't be 10 feet near a property line, can't have, this many kilowatt hours concentrated in one spot. You start getting into all these. So you think, oh, I just have this little battery. I'm going to put it in a parking spot. And then the city planners are like, no, you're not. 10 years ago, when that hotel was built, the deal was cut. You need this many parking spots for this many rooms. You can't take one. So you're like, what do you mean? No one ever parks here. They're like, nope, can't do it. Find another spot. And then it starts to really become space constrained. The place where you end up putting them is by the trash, because someone thought long and hard about where to put something they don't want. And that's called trash. And your battery is going to go right next to that trash receptacle, more than likely, 9 times out of 10. So that's the siting question. I have seen underground solutions, which is quite creative, but then you get into how do you O&M that battery? It's easier to install. And then there was another part to the question, the 3 questions besides.
Yeah, so the space, the indoor, and now I'm forgetting the third piece. What was it? It was around
they need HVAC too. They're very fussy around temperature.
without a battery storage only. So what
so storage only. I have done a couple storage only projects and they make a ton of sense. Like if you have only a very limited budget, the customer, especially if you're in a place with high demand charges or high spreads between peak and off-peak rates where you can do time of use shifting, a battery should be the first purchase. If they could only purchase battery or solar, they should buy a battery first. And the reason is, if you look at their bill, the energy portion of the bill, as opposed to the demand portion of the bill, they might only be paying, 20 cents a kilowatt hour. Well, it might be hard for you to build solar for less than that, right? Whereas you can spend a lot less money on a small battery and start attacking that peak demand charge right away, or attacking that arbitrage opportunity between peak and off peak right away. So, your greatest savings from the battery start with that first kilowatt hour you put on the pavement. And then it declines over time because once you have mitigated that peak demand charge, there's very little more. To Jonas's point, you can't really attack that non-coincident demand charge. That 24-hour-a-day demand charge is you're going to nibble away at it. It's sort of like running a mile. Like if you're like totally out of shape, and getting from your 12-minute mile down to your 8-minute mile is pretty easy, right? But if you're already running a 4-minute mile, getting down to a 3-minute and 50-second is like incredibly difficult. So that's like the sizing of the battery, right? Your first little battery you put on there is very cost effective.
Yeah.
One quick comment on space constraint. I mean, I think we're seeing more and more architectures now that are a fully integrated system, single cabinet. So historically, we're looking at a DC block of batteries paired with a separate inverter cabinet. More and more, everybody saw at RE Plus, a single cabinet that has maybe inverters on the top and the DC block underneath. I think that's one thing we're seeing as a way to handle some of these very tight or very space constrained environments. And it seems like a novel solution there that may get more and more traction on it. The other aspect of that, and again, I think this kind of goes back to where the market was maybe 3-4 years ago. The containerized systems where it was a 10, 20, 40 foot shipping container, those seem to be very much out of vogue unless it's a utility scale project where you have lots of space. So I don't, we haven't deployed anything that's been containerized. I don't think, Dan, you are either. Jonas, you might be seeing some of those, but kind of the cabinet based solutions are the way that people are handling a lot of those space constraint considerations.
Yeah. Yeah. And we're seeing both all-in-one cabinets, right? You're saying with the battery inverter built in, as well as, we do have a few kind of more industrial scale customers that actually prefer containers just because they think somehow it's easier to move and more protected. But in general, I think almost, from the logistics perspective of moving cabinets versus container, it's yeah, it's really powerful stuff. We have just a couple
Alex,
minutes here.
I
Go
want to
ahead,
add
please.
one quick thing just to that. And I think it's just important if you do like a battery only solution, and I think it's important why you work with somebody like GridVest.
I'm not quite sure how to help you.
There's a lot of batteries out there, and they're actually quite available. But it is important that you work with a battery solution that is certified for non-export and have all the certifications. And it's pretty simple. They need to be, if you're on a battery that's on the California Energy Commission approved vendor list, then you're good to go. And because there's a lot of batteries that are not, everything GridVest sells is on those lists, and which is why I work with them. But if you do battery only, you can't charge from the grid and then discharge it back to them and sell back to them. And so there's nuances there, and so working with somebody like GridVest, you skirt that. And then if you get a battery that isn't on that list, you start getting into non-export relays, which become unbelievably complicated and extremely expensive. And so anyway, use certified non-export solutions like GridVest sells, and so battery only solutions have complexities unless you're using the right equipment. So
Appreciate that, Jonas. And yeah, totally agreed. Do you have a sense, does anyone want to chime in on the future of, on that note, like UL certifications, any pending changes that we should know about, or any gotchas that maybe, people who are on the webinar might want to keep in mind? In addition to Jonas, I think we said the CEC list is the, probably easiest to use as a barometer. But anything else or any other, because I know there are some changes coming in 2025.
Yeah, so to Jonas's point on non-export, I find that critical to avoid some nasty metering requirements in California that add like 9 months to my project. So we've been doing it through, so inverters are certified to UL 1741 standard, in particular supplement B in California, and you can get them certified to non-export by doing, it's called a CRD for PCS. That standard has proven so popular among developers that UL, being the mafia that it is, has chosen to make it its own new, unique standard that everyone needs to get certified to, called 3141. So the CRD will be superseded by 3141. California's already taking that UL, and that will be very important for us. The other one that's super important is around 2017, 2018, the solar industry came up with rapid shutdown requirements, and it added a ton of cost to projects under the guise of safety. Companies like Solar Edge could sell optimizers every 2 panels. So every 2 panels, you're spending $40 on a new device that's supposed to shut stuff down. In reality, I don't know how many fires they've prevented. I've had roof fires, not on my projects, but on my friends' projects that had rapid shutdown devices on it. So it certainly didn't save a roof fire in those instances. There is a new UL code called, I think it's 3741, where you can avoid those module level power electronics as long as your inverters and racking is certified together. And so it goes on the roof. The inverters need to be like inside the array, like within 1 foot of the array boundary, and then you can satisfy the rapid shutdown requirements under that new standard without all those little pieces that go on every single panel. So it saves a ton on labor, and your mileage may vary, but that's something I'm tracking. And Mayfield Renewables is a really good engineering firm. They put on a lot of really good webinars like this that talk about these standards. But with both of these, both 3141 and I think it's 3741, they're holistic standards. It's not just to one inverter, right? It's the inverter plus the racking certified together, right? Same with 3141. It's not just the inverter, it's the controller. So it has to be certified with Jonas's controller and the meters, technically. Now, whether they ever enforce all this in the field, I don't know. But in theory, it's a whole system that's getting certified together. And if you take off any one of those pieces, it breaks the UL. And
What do
that's,
you think? How do you think that's going to change the way that that systems are sourced and sold? Especially thinking about integrators, thinking about new cells, right? Because, new cells are coming out so frequently now, that we end up in the US getting stuck with sometimes the older models because no one wants to go ahead and do all the new UL certifications on the new cell and to do the whole process they just went through. So do you have any insight into when those UL certification requirements are going to take effect, and B, and I'd love to hear other thoughts on this too. How's it going to affect the equipment side and the supplier side and the integrator side? It's a big
I think
yeah,
it
I'm not an expert. I would defer to, maybe Jonas as a technical, mind on this, or I don't know. Scott, are you
I think
feeling?
yeah, so a little bit. I think what we're seeing is more and more where the paired solutions are going to be harder and harder, right? So looking at a solar arc with a separate battery, can work today under CEC listings, but that's going to become harder as we look at some of these standards. As Dan said, I mean, it's an integrated UL listing, so you can't change your EMS or your enclosure or something else if they are all integrated. So I think that's going to become more and more important on that side of it. But Jonas, you want to comment more?
I agree. I mean, we saw this in the past with the panels and the racking, and it put a big pause in the industry. Sadly, I'm not up to speed on these forthcoming changes, but they did this once before, and so from our perspective, we work. I'm more on the project side of things, but we also work on the enterprise side of things, and so we're working at the manufacturer level, and they would essentially engage with us at the manufacturer side and embed our EMS within their PCS directly or as a component to the PCS, and so we essentially move upstream in our process and install EMS at factory. It has to become part of the UL process for the enterprise folks.
Great.
Yeah, I think on the flip side, I think it accelerates project development, right? So if we're not going to have to wait for utilities to approve things because they are on approved list, that certainly makes all of our lives as developers, as installers, a lot easier. The utilities don't have a way to fight projects, and frankly, that's what we're seeing. At the end of the day, as much as we want to work with utilities, they are less incentivized to work with us. That's pretty much across the country. They do, I don't want to say see us as the enemy, but we're certainly not as complementary as we have played that out. So, anything we can do to reduce friction with the utility, I think is beneficial.
Yeah, no, totally. Well, that's been a great panel, guys. I really appreciate your time, your wisdom. I want to give you each 15 seconds for any final words that you'd like to add, or any even just well wishes to the industry, and then we'll close it out. So, any final thoughts?
Just happy holidays. And no matter what's happening with the administration, you just got to stay the course. We got to get to a world running on renewable energy. There's no reason we cannot. We have the technology. We need to implement it.
Amazing.
Yeah, I'll echo it. It's an all of the above on energy. It's an all of the above on teaming. So feel free to reach out to any of us, and we'd be happy to help.
Agreed. Yeah. You can contact all of us on LinkedIn or through Alex if you have any questions. Appreciate everybody being here. Happy holidays, everyone.
Great. Well, thank you for that. And thanks everyone for joining, simplifying the deployment of behind the meter storage. We hope that you found it insightful. And I hope it really helps you to navigate 2025. This is going to be a beginning of a series of webinars that GridVest will be hosting, and just talking through common challenges in the industry, getting expert input, and ideally collecting the best of knowledge and suppliers as well. We'll be having some of our featured supplier partners and some more case studies from real projects. So hopefully, once a quarter, keep an eye out for us, and we'll be doing this more regularly. So if you haven't signed up for our newsletter, make sure to do that. Follow us on LinkedIn. A recording of today's session will be available in the next few days. We'll send out an email and post the link. But thank you again so much for joining us right before the holidays. We're excited to see how this takes, you can take this work and this knowledge and this mission I think that we're on, and to move it forward, because battery storage is needed. It's a crucial part of our energy infrastructure, and accessibility of energy and resilience of energy is so crucial for humanity. So thank you all. Thanks for your time, and have a great holiday. Bye, everyone.
Thank you.